Hello, ladies and gentlemen of Geometry B. This is the last part of, should be Unit 6, not Unit 7, so that's a mistake. That should be 6.7. Talking about the law of cosines. We talked about the law of sines, and now I want to compare the law of cosines to this and kind of show you where they're different. So, law of cosines is similar to the law of sines in that it will work on any non-right triangle. That's where you're using this, non-right triangles, so no right angles. It's different because you use this when there's not an opposite side, opposite angle relationship. So, law of sines, you want to use anytime you've got some sort of opposite side, opposite angle relationship. You can use it to solve for angles or for sides. Law of cosines, you're going to use if you've got a side angle side situation where you've got the side, two sides, and the angle in between, or you've got three sides. So you've got a side, side, side situation, and you're looking for an angle. All right, so law of sines, you have to have this relationship of an angle and a side. If not, and there's no right angle, okay, so remember there's no right angles here, then I want to use the law of cosines. So no right angles, none of this, I'm using law of cosines. So here's kind of what the law of cosines says. All right, for any side, so for side A, side B, side C, okay, for this first part, it almost looks like, this first part almost looks kind of like Pythagorean theorem. So c squared is equal to a squared plus b squared minus 2ab times the cosine of angle C. So what this means is this, and don't worry about memorizing this. You have your sheet that has this on here. For any given side squared, that's going to be equal to the other two sides squared and added together minus double that product times the cosine of the angle. Okay, so a side squared equals other side squared added together minus 2 times these times the cosine of your angle. All right, so if you look at order of operations, you're going to square this, multiply all this together first, then add this, and subtract this. So you got order of operations, of course, comes into play here, so you got to remember to keep that straight. So let's take a look at what we're doing here. We're trying to figure out this length, BC. So that's kind of like length A. What we know is that A squared is going to be equal to B squared plus C squared, so that'd be 21 squared plus 42 squared minus 2 times 21 times 42 times the cosine of 39. All right, so a lot going on, a lot of order of operations stuff that I got to keep straight. So A squared equals 21 squared is 441. 42 squared is 1764. If I multiply all this together, I get 1370.89. So I'm going to add those, 441 plus 1764 minus 1370.89. So A squared is going to give me 834.11. So now to solve, I'm going to square root that. So my answer is going to be 28.881. So that's going to be my answer, 28.881. Boom. That's what I'm going to deal with. So now, once again, I'm trying to figure out this length B. So it's a similar setup to the one before. So if I come over here and I can keep that law of cosines up there so I can have it, it's more about recognizing when I have to use it and knowing what to do here. So I'm going to take B squared, and that's going to be equal to 18 squared plus 26 squared minus double 18 times 26 and take the cosine of 26. All right, so 18 squared plus 26 squared. So that's going to be 324 plus 26 squared is going to be 676. Then I want to multiply all of this together. 2 times 18 times 26 times the cosine of 26. Notice I'm always using cosine. That's where this rule comes from, Law of Cosines. So I'm putting all this together. So b squared is going to be equal to 324 plus 676. So after all that, I get 158.729. And if I take the square root, I get 12.6, essentially. So how long is this thing? This thing's going to be 12.6. So if I look over here, figure out the length of A and B. So here is where I would use Law of Sines. All right, so this is just that recap of recognizing I've got this relationship. That relationship means I want to figure out what the law of sines. So how would I do that? So this is actually a law of sines problem. So I want to take sine of 38 over 12 will be equal to the sine of 85 over b. So I will take 12 times the sine of 85 equals sine of 38 times b. So sine of 85 times 12 is going to be 11.95. And then if I divide that by the sine of 38, I get b to be 19.4171. So b equals 19.41, or 42 rather, if you want to round it. So that's 19.42. So to figure out a, well, a triangle has always got to add up to 180. So that means this angle's got to be 57. So now I'm going to run that one more time. So I'm going to say sine of 38 over 12 is going to be equal to the sine of 57 over a. So same kind of idea. But it's about recognizing that this is where I would use the law of sines to solve my problem. So go boom, boom. So sine of 57 times 12 equals sine of 38 times a. So when I do that, I should get 10.064. Then if I divide by sine of 38, a should equal 16.3467. So that's my answer. So now that gives me all three sides of that, but it's more about recognizing, hey, I've got this relationship. That's got to be my big tip-off that I'm using law of sine. All right, so let's take a look here. DEF, figure out e to the nearest 100th, so that's 2 decimal points. So I've got this kind of situation where I want to say e squared is going to be 6 squared plus 18 squared minus double 6 and 18 times the cosine of 88. So 6 squared is 36. 18 squared is 324. Two times 6 times 18 is going to be 216 times the cosine of 88. And when I do that, I get something really, really small. So 36 plus 324 is going to be 360. minus 7.53829. So when I subtract that, so I'm going to get e squared equals that. .462, not 426. 462, and then when I square root it, I get 18.77. So that's my length to the nearest hundredth. So that's how big E is. It's going to be 18.77. So now if I look over here at number 2, two ships are sailing from Halifax. The Nina is sailing due east, and the Pinta is sailing 43 degrees south of east. So it's going here, and that's going to be 43 degrees. After an hour, the Nina has traveled 115 kilometers, and the Pinta has traveled 98 kilometers. How far apart are the two ships? So I'm looking for how big is this distance. So if I set this up, so I'm going to have, I'll just call this, A. So A squared would be equal to 98 squared plus 115 squared minus double those times the cosine of 43. So now getting to work, 98 squared, 9604, 115 squared is 13,225. 2 times 98 times 115. Multiply that times cosine of 43 is going to be 16484.7. So when I put all this together, A squared is going to equal 6344.3. Square root my answer. That's going to be 79.65. So approximately 79.65 kilometers. They're about 80 kilometers apart when they do that. All right, so that's kind of all I got. Play around with this. And be careful with your order of operations. Be careful with your setup. That's where the game is won or lost. And then play around with this and come talk to me with questions.